Welcome back. So here it is, our example on the uniform distribution. So let's say the buses are arriving at a specified stop at 15 minutes intervals starting at 7 a.m. So buses are coming at 7, 7:15, 7:30, 7:45, and so on. A passenger arrives at the stop at a time that is uniformly distributed between 7 and 7:30. And then we have to find, so what does that mean? That a passenger arrives at the stop at a time that is uniformly distributed between 7 and 7:30. Well, what it means is that the arrival time, if you think about the arrival time as a variable, as a random variable, then we are saying that that arrival time variable has uniform distribution over the interval from 7 to 7:30. We need to find the following probabilities. So what's the probability that the passenger waits less than 5 minutes for a bus? And what's the probability that he waits more than 10 minutes for the bus? Okay, so those are the two questions that we need to answer. So first of all, to answer this question, I made this interval from 7 o'clock to 7:30, and so we are going to denote by X the arrival time of a passenger, but instead of going from 7 to 7:30, let's do the following. We're going to label 7 a.m. as time 0, and then the 7:30 a.m. will be labeled as 30 or 30 minutes past 7 a.m. So X is the arrival time of the passenger. So in other words, we are assuming the passenger arrives at the stop X minutes past 7 a.m. So since we are assuming that X has uniform distribution, then over the interval from 0 to 30, its density f of x will be given by 1 over 30. So remember for the uniform distribution, this is the uniform distribution of over the interval from alpha to beta. The density is given by 1 over beta minus alpha, or 0. So here in our case, beta is 30 and alpha is 0, so f of x would be 1 over 30, and when x is between 0 and 30, and it'll be 0 otherwise. So now we know the density of the arrival time now, so we can answer the probability questions now. So let's look at A. So we want to know what's the probability that the passenger waits less than 5 minutes for a bus. Well, if you think about it, if he's waiting less than 5 minutes, then he has to arrive between 7:10 and 7:15, or he has to arrive between 7:25 and 7:30. In other words, in terms of the clock from 0 to 30, it means that the value of x has to be between 10 and 15, or the value of x has to be between 25 and 30. So then we are asking, what's the probability that x is between 10 and 15, or x is between 25 and 30? Now, these two events are the event that x is between 10 and 15 and the event that x is between 25 and 30. They are disjoint. So we can, so they're disjoint. So I can write this probability as the probability that x is between 10 and 15 plus the probability that x is between 25 and 30. Now, as we know, the probability that x is between 10 and 15 would be the integral from 10 to 15 of the PDF. So you integrate the PDF, and the PDF would be 1 over 30 dx. Remember, this is the value of the PDF when x is between 0 and 30. And then from this, the probability that x is between 25 and 30 will be given by the integral from 25 to 30 of 1 over 30 dx. And then if we calculate these two integrals and add them up, we get 1/3. Okay, so now let's look at the second question. It says, what's the probability that the passenger waits more than 10 minutes? Well, if he waits more than 10 minutes, that would mean that he has to arrive before 7:05 a.m. That is, x would have to be less than 5, or he has to arrive in between 15 and 20, or that is, in other words, he has to arrive between 7:15 and 7:20. So in other words, we have to find the probability that x is between 0 and 5, and the probability that x is between 15 and 20, and then add them up. And so if you go ahead and calculate those two probabilities by writing them in terms of the integrals, you'll see that you get 1/3. So I'll let you write these two probabilities in part B, just like the way we did it in part A, and calculate them on your own, and you'll see that you get 1/3. Okay, so that's the end of this example.